All right, folks, today I'm going to be talking about inverters, AND gates, and OR gates, and how we're going to make them out of NAND-only gates. So we're going to be able to take a NAND gate, we're going to be able to build all of our AOI logic, we're going to be able to build all of that just with the NAND gates. I think that's pretty cool. You can actually build anything out of only NAND gates. Now, you may have even heard of NAND-only flash or NAND flash memory. Right? There's a lot of things out there in this world made out of NAND gates. Now, let's take a look at what we can do with this. Now, an inverter, right, takes a signal, it takes a 0 and turns it into a 1. Now, if we have a NAND gate is just the opposite of an AND gate. A NAND gate, if any of those things don't match, a NAND gate outputs a 1. And if the two inputs match, it outputs a 0. Therefore, what we're going to do is create an inverter. We want something where if the two inputs match, it outputs a 0. Well, if we have two 1s, those match and they output a 0. Therefore, we're going to take our NAND gate, which looks like this. We're just going to wire the two inputs together. That turns it into an inverter. Right? All that does is, if I have a 1 on here, right, both the inputs to this gate are a 1. 1 and 1 is 1. Inverted is a 0. If I have two 0s on here, 0 and 0, that matches. 0 and 0 is 1. Therefore, that becomes a 0. NAND gate with the two inputs tied together is an inverter. Now, this is pretty handy because the NAND gate is just the opposite of an AND gate. So if I have a NAND gate and I can build an inverter out of another NAND gate, I can just take a NAND gate, convert that into an AND gate. So I'm going to go ahead, I'm going to take a NAND gate, wire it up to my two inputs. Then I'm just going to go ahead and I'm going to invert that. And there we go. Now we have an AND gate. It's built out of two NAND gates, yeah. And that may seem inefficient to some of you, but the reality of it is that in the real world, if you just have a warehouse full of NAND gates, that's all you need to do anything you do. You don't need to stock a lot of parts. It's actually cheaper to only have NAND gates around and use a few more on every single in every single project than it is to have all these different components sitting around. Right? It's a handy little trick that can save companies a lot of money. Now, the last thing we have to be able to make is we need to be able to make an OR gate. Now, the way we do that, and if you're a little skeptical on this one, you're just going to have to refer to the PowerPoint because I don't really want to take the time in the video right now to go over it. You can also certainly just ask me. But you're going to need 3 gates to do this one. So you're going to take your 3 NAND gates. You're going to wire 2 of those NAND gates to the input of the last one. And then you're going to tie the first 2 together as inverters. So you can see in each one of these cases, we have the same number of inputs and outputs at the end, right? Our inverter has 1 input, 1 output. Our AND gate has 2 inputs, 1 output. Our OR gate has 2 inputs, 1 output. Each one uses successively more NAND gates, but you know what? Like I was saying earlier, having more NAND gates isn't a bad thing, right? NAND gates are versatile. You can make anything out of them, so it's good to have them. And it doesn't matter if you're going to use a few extra. All right. This is just the first part of our NAND-only logic video. I'm going to show you the next part. In the next part, how we take an AOI circuit like this one and convert it into only NAND gates. All right, thanks for watching.